Hello class, today we're talking about scientific notation. So scientific notation is a shorthand way of writing really big or really small numbers. In scientific notation, a number is written as the product of two factors. Example, if I had this number 280 million, we can write that as this smaller number. So scientific notation has that multiplication in the middle. Regular notation is just the standard way of writing it, so it actually includes all those zeros at the end. So the main reason we do this is because we don't want to have to keep writing 0, 0, 0, 0, 0, 0, 0 over and over again. We can just kind of clean it up a little bit. Scientific notation is made up of three parts. You've got the coefficient, you've got the base, and then you've got the exponent. So the coefficient is that number in front. This is the coefficient. It's always going to be between 1 and 10. The base is always 10, and you have your exponent, and that is going to tell you how many times you move the decimal point. So if a number is really big, it's going to have a positive exponent, and if the number is really small, it's going to have a negative exponent. And that kind of goes along with the powers of 10 we've been talking about before, whether we had something like 10 to the negative 6, or maybe it was 10 to the negative 2. We remembered that making it into a fraction. So, to compare two numbers given in scientific notation, first you're going to look at the exponents. So the one that has the greater exponent is going to be bigger. The bigger the exponent, the bigger the number. If the exponents are the same, though, if they're the same, then you compare the decimals in front. And we're going to get to some examples down below. So first, you're going to move the decimal the same number of places as the exponent. You're going to move the decimal to the left if your number is negative, and you're going to move the decimal to the right if your exponent is positive. So let's get into some examples. 5 times 10 to the 6th, and I'm going to write it a different way. I'm going to include the multiplication sign in the middle. 5 times 10 to the 6th. That means I'm going to start with 5. I'm going to look at where the decimal is, and when it's a whole number, remember the decimal is right at the end of the number. And I'm going to take that decimal and move it 6 times to the right because the exponent is positive. So I'm going to go 1, 2, 3, 4, 5. I'm going to fill in those little blanks with zeros, and I end up with a new number. I have 5 with 6 zeros afterwards. Same thing happens with your negative exponent. And again, I'm going to try to clean this up a little bit. 8.3, I'm going to put that multiplication symbol in the middle because that's normally how you'll see it. So I'm going to start with 8.3, and I'm going to take the decimal and I'm going to move it 4 times because my exponent is 4. But this time, because my exponent is negative, I'm going to move it to the left. So 1, 2, 3, 4. I'm going to fill in those blanks with zeros. I'm also going to put one more on the other side. So now I have my new number, 0.00083. So now we're going to order these because a big part of the scientific notation is just ordering them, figuring out which one comes first. So when we're ordering from least to greatest, we're going to start with the smallest number and then go all the way up to the biggest. So when we're doing scientific notation, the first thing we really want to look at is all the exponents. So if I'm looking, so I know these have negative 3's, but it looks like negative 4 is going to be smaller and negative 5 is going to be even smaller than that. So my first number is going to be 7.43 times 10 to the negative 5th. Next, I've got 2.5 times 10 to the negative 4th. Next, I've got negative 3's as the exponent, so I know those are going to be last, but then I have to think, well, because they both have negative 3's, which one is going to be the smallest and which one is going to be the biggest? Well, because they're the same, let's just look at the numbers in front. 3.1 is definitely smaller than 7.8. So 3.1 times 10 to the negative 3 is going to be next, and then 7.8 times 10 to the negative 3 is going to be last. Finally, and I think this is the easiest part, we just have to compare two numbers to figure out which is the biggest and which is the smallest. Again, using that same trick with the exponents, if I have a 5 here, and I have a negative 7 here, my biggest number is going to be the one with the biggest exponent. In this case, 5 is bigger than negative 7, so this number is greater than this number. Again, just look at your exponents. 4 is smaller than 6, which means this whole number is going to be smaller than this whole number. Next, I've got negative 2, and I've got negative 6. Negative 2 is greater than negative 6. And then lastly, because they are the same, we have to look at the numbers in front. In this case, 5.27 is greater than 2.139. There are a couple that I want you guys to do on your own, and when we come back as a class, I'll kind of give you the answers and we can talk about it some more.